When building a FAT table in a retail industry, you are always faced with a very important decision to make. Should one row in my FAT table represent one completed customer order, or should one row represent each product line inside that order? Now, this sounds like a very simple design choice, right? But this decision affects how you count orders, how you calculate revenue, analyze products, calculate quantity sold, discount, margins, and analyze customer purchase behavior. And if you get this grain wrong, your query might run successfully, but your result will be misleading. So in this video, we will start from a normalized grocery retail database, then work our way to build the FAT tables together. When you look at this ARS diagram, you will notice that we've got 17 well-modeled tables here, but out of these 17, we are going to work with only 4. And these 4 are the orders table, the order items table, the products table, and the payments table. If you carefully look at everything here, and I'm going to drop the link to download this database so you can install it in your Postgres database. All right. So when you look at these tables, you will notice that these tables mirror what you usually see in a normal retail database or e-commerce application. So the order table stores the completed customer order, or you can call it receipt, while the order items table stores the product or item that the person purchased inside that order. So, if one customer buys milk, bread, rice, and apple in one visit, that may be one row in the orders table, but 4 rows in the order items table. Now you see the difference. And that is exactly why grain matters. Now let's take a look at some of the tables we'll be using in this demo. I'll start with the orders table. So this is the query interface. I will paste the order table here. Here I am picking all these fields from the orders table, and this is the database. So I will run it. All right. This is awesome. Now take a look at the order tables. One row equals one order, one completed purchase, one receipt. It tells us who bought, where they bought, when they bought, and through which channel they made their purchase. However, it does not tell us the products inside the orders. To be able to get that level of details, we need to try another table, and that is the order items table. So let's take a look at that. All right, so I'm going to paste this here and we'll run it. Good. So here is the order items table. Now notice the difference. The same order IDs can appear multiple times. That is because one order can contain multiple product lines or items. This table is at a lower grain than the orders table. The orders table is the order level. The order items table is the order line level. And this decision is the foundation of today's video. Great. So now let's build the FAT tables. We will start with the transaction grain. Now in this FAT table, one row represents one completed order. So let's build it gradually. First, we will start with the orders table and gradually build it. Let's select these rows from the orders table. I'll drag this down. So I'm getting these rows. These are the rows we are getting from the orders table. Good. Now, this gives us the base transaction record. At this point, we have the orders itself. But a FAT table usually will need measures because there is really no FAT table without measure. So for this, we will need the item count, the gross amount, discount amount, tax amount, net amount, and the total amount. And just like in most transactional databases, these measures are not directly stored in the orders table. They come from the order items table. So to do this, we will need to join our current table to the order items. Good.
All right, so I'm going to now paste this.
I'll drag this down so we can see the entire query. Excellent. That will run it, and we have this. Awesome. So now let's take a pause and carefully go through this table. This is the key part. Because our grain is one row per order, we must group at the order level columns. And that is what makes this a transaction grain facts table. All right. The next thing we will do is to add the payment method. Payments, as we know, relates to the order level. It doesn't relate to the individual product, except if a particular product is the only thing you purchased. So payment is related to a full order, not to each product line. So we will then join the payments table to the existing table now.
All right, so I will create a space for this and paste this code.
Drag it down a little more. Excellent. Now when you carefully look at this code, you will understand that this is now a proper transaction grain results. One row per completed order. Now I want you to note something. You can add as many orders as needed to answer the business question. Nothing more. You do not have business with anything extra. Focus on answering the business question. So for us, this answers the business question, and that's why we focus on this. All right. So I will run it, and to be sure that we are getting the desired result. Excellent. Yes, we got the desired result. Good. Now it is time to build this fact table. Okay, so let's pick up a new window and build it there. So I'll paste this code. This query will first drop the schema if it exists and everything that is downstream this schema, like every other table that depends on this particular schema. But if it doesn't exist, it will create it. Excellent. So, and then after creating the schema, it will now create this table, which is the query we actually formed in the course of trying to build the facts table. And when it is done creating it, what happens here is it will alter the table and make the transaction ID the primary key. That's all it needed to do. And when it does it, we are good to go. All right, so I'm going to head on and run this code. Excellent. It's run successfully. Good. For us to be sure that this has run successfully, what we need to now do is to go to schema, refresh this, and find that schema that we created. And you'll see that schema, the grocery underscore data warehouse, and you can also see it here. Excellent. So this is correct. And if you expand it, you will see the table that we created. All right. So now let's expand it and go to table. And then you will see the table that we created. And that's the third. And here is the table, the fact based transaction table. Excellent. So we have achieved this. Okay. We're not just going to relax because we have created this table successfully. What we need to do right now is to try and run what we have created to see that it truly works. So I'm going to paste this code, and all this does is to select all the fields from this table. That's all. And order it by the transaction ID, which is now the primary key. Good, and you see that our table truly exists. Now let's also confirm the count. So I'll paste the query here and run the count. Excellent. So you see that we've got like 60,000 rows of data. Good. This is very impressive. Another way to validate what you have done is to also run another query to ensure that this count matches exactly the number of rows in your completed orders table. And when they match, then that's another level of validation that you actually got the right grain. Excellent. Now let's run a simple transaction level query. This simply gets us the store ID, the transaction count, that is the total count, and it gets us the total sales, average transaction value from this our facts table, and then it grouped it by the store ID because we have an aggregation there, and then order by total sales and in descending order. So I'm going to run this, and now when you look at this, because we ordered by the total sales, you notice that store 5 has the most sales. That is an excellent work. Here are some of the questions this facts table is designed to answer. And these are things like the transaction counts, the total sales, the average transaction value, payment method analysis, order channel analysis, and store level sales. And you can perform as many analyses as possible within the facts table. And because the product does not exist in this grain, it cannot perform product level analysis. And that brings us to the second facts table. Excellent. And this facts table is the sales line facts table. You could name it whatever you like based on what the business agrees that you should name it. So in this facts table, the grain is order line item, and one row represents one line item inside an order. So let's build it. All right, so I'll paste this query here. Notice in this query that we did not group anything. So I'm going to try to scroll it up. Yeah, this is better for me. We did not group the data, and that is intentional because the grain is the line order. If a single order has 4 products, this facts table should have 4 rows for that single order. All right, let's run it. And this is the level of details we have for the order line item. Good, but this is not enough. What we now want to do is to create the measure we need for this facts table. And you know, there is no facts table without a measure. Measure is the reason for the facts table. Good, let's paste the query. Okay, so let's scroll down. And this query is now at the sales line grain. So let us run it and see. Excellent. So in this result, you notice that each row describes one product sold in one transaction. So this table will be able to answer questions like, which product sold the most? Which category generated the most revenue? Which products are the most profitable? How many units were sold? And which promotion affected product sales? And so many other analyses you can perform with this facts table. So now that we have the right query, let's build the physical table. Okay, so I'll paste my query here. So in this query, notice that we did not create the schema because we want to maintain the same schema, but we created a new table, and that new table is facts sales line item. And then you can see the query that powers it. So it says create table facts sales line item as then the query that follows. So after creating the table, the next thing you notice is the alter table. It will go on, alter the table, and then make the transaction ID and the line item the primary key. Notice that the primary key are a combination of 2 fields. For transaction facts table, the primary key was the transaction ID. But for this line item facts table, the primary key becomes a combination of the transaction ID and the line number. And this is because one transaction has multiple lines. Hence, transaction ID alone is not suitable to build this facts table because it's not going to be unique. And this is another practical way grain shows up in data modeling. The grain affects the primary key. And when you build your fact table with a combination of columns like this, we call this composite key. Alright, now let's run the query so we can build the table.
And we are able to build it successfully. Excellent job. We are doing amazing so far. So let's inspect our work. I'll paste this. I want to just select everything, the first 20 rows. And this is the first 20 rows. And then you will see all the fields that we just created. Let's refresh the number of tables. It is still showing one table here. But when we click and refresh, you will notice that we will have two tables here. And this is the second table, which we are running right now. Excellent. Let's also check the row count. Paste this here and run it. This row count, we have over 205,000 rows. And when you compare it to the previous fact table, which is about 60,000 rows, you will notice that this count is larger than the transactional fact table by far. And this is expected. It doesn't really mean that we have more transactions. No, it means we are now at a lower grain, and one order in this table can have multiple product line or product item. Now let me show you a simple but very harmful and costly mistake that you can make. In this query, we did a simple count of the transaction ID and a distinct count of the same transaction ID. The first one as the incorrect transaction count and the second one as the correct transaction count. Good, and they are all coming from our new fact table. Good, so I'm going to run this and you will see the difference. Excellent. You notice the first one gave us the total count of every row, but it tells us that this is the total transaction count. And the second one says, no, the total transaction count is not that big. It is just this 60,000. So about 3 times lower. And this is one of the clearest ways to explain grain. The same table, the same column, but different logic. One result ignores the grain and the other result respects the grain. And that is why understanding the grain matters before writing your first line of SQL query. Excellent. So now let's try and run a simple analysis at the level of products. Good. So I'll paste this query and you will see all the things we want, like the product category, the product name, song aggregation, and then we'll group it by those categories like the product name and the product category. Good. So I'm going to run this and then you will see this. So you see what we have done. This query works because the fact table grain supports product level analysis. Now, each row has a product, each row has quantity, each row has unit price, cost, discount, net amount, and profit. So if the business asks which products are driving sales, this is the right fact table. The transaction fact table cannot answer this question because it does not carry this level of granularity, the product level details. Now let's compare the both fact tables. Good. So I'm going to paste this, and here you will notice this first data is coming from the fact test transaction and this is coming from the fact sales line item. So we want to easily count the number of rows from each of these tables. So you notice them, one is 60,000, the other one is over 205,000. The transaction table has fewer rows. The sales line grain has far more rows, but they are both correct at this level of details. Remember, we are now counting the number of rows from the fact sales table and the number of rows from the fact sales line table. These are completely different tables. And when you perform this level of calculation, you will be sure what you are doing. Both are correct. They just represent different levels of details. So now let's compare their total sales so you will see the amazing work here. Alright, so I will paste this Before I run it, what this is telling us is get us the total amount, and this is coming from this fat sales transaction table, and the other one is coming from the fat sales line item table. And then let's run it and see. Excellent. So you can see this. Now, the total should align because both tables describe the same business process, but they are not interchangeable. We're talking about the same order. Whether you calculate it at the level of order or at the product level detail, they should give you the same total sales because it is the same transaction. The transaction facts table here is better for the transaction level questions. The sales line facts table is best for product level questions, and that is the balance you need to understand as a data engineer or analytics engineer or BI developer. So let's summarize this. We started from our normalized OLTP retail database. OLTP stands for online transaction process. We looked at the orders table where one row represents one customer order. We also looked at the order items. Here one row represents each product line inside that order. Then we built two fat tables. The first one was the fat sales transaction table. Each grain is one row per completed transaction. And the second one was a fat sales line item, and each grain is one row per product line inside a particular transaction. So when next you want to build a fat table, you should understand the grain first. That is because the grain is not just a definition. The grain affects your joins, your aggregation, your choice of primary key, your SQL query logic, and the question that fat table is meant to answer. No other question. It should answer that question only. And that brings us to the end of this video. In the next video, we will take a look at the same idea but in the healthcare sector, where the grain becomes even more interesting because one patient can have multiple visits and one visit can have multiple treatments. If you find this video useful, please give it a like. This is good for the YouTube algorithm. And if you are new in this channel, I will say thank you. Thank you for visiting my channel. Please consider subscribing to our channel. We are growing. We are getting better. Trust me, we build things that you will need at your work. And we build things that will help businesses make better and informed decisions with their data. And if you are my returning subscribers, you are the MVP. You know yourself, and I say thank you for believing in me. Guys, share this video with your friends. Share it in all the social media platforms. Let them enjoy this. Let them really build things that truly answer the questions that the business unit wants it to answer. And until I see you again, keep analyzing.